Now, a comment on naming organic compounds. It does seem kind of like there's a lot that goes into it, and there is. And typically, you're not going to be given some like abomination to name. But if you can name the abominations, you can definitely name the simpler compounds. But there is a rhyme and a reason behind why we have the priority rules for naming organic compounds. So why does an alcohol take precedence over something like an alkene or an alkyne, a double bond or a triple bond? Why are halogens and branches considered equivalent in the naming schemes? Well, the reason is simple. It has to boil down to reactivity. So if we were to take an alcohol and have a double bond somewhere along the compound, we would find that the alcohol is far more reactive towards anything we throw in there than something like the double bond. So if we have something like HCl, the HCl is not as likely to add across a double bond as it is to replace the alcohol to give us a Cl, an alkyl halide. So when we look at the naming, you probably don't know a priori which group is more reactive than another. That's fine, but use that as guiding you in terms of when you do a reaction to something, what you think is going to be the primary functional group that gets reacted. So if we have something like an alkyl halide or a branch, it's not likely that either one's going to be more favorable than the other depending on what reaction we're working with. But definitely if we have something like a triple bond and an alcohol in the same group, anything we react that triple bond with is probably going to be also reacted towards the alcohol. So we have to consider either protecting the alcohol or accepting that we're going to react it away. So again, with successive videos, if you're curious where this naming scheme comes from, where it really comes from is that the group that's most reactive is going to be the one that takes priority in terms of ordering carbon chains because that's most likely the position we're going to worry about first.